Hi, how are you? Nice to meet you, by the way. Let me introduce myself first. My name is Christina. You can call me Miss Tina. So in this lesson, I will show you how to find the stationary point and determine the nature of this point. Okay, so then without taking any longer time, let's get started. I will share my screen first. I hope that you already can see my screen, or maybe still loading, I guess. Okay, so I will maximize. Okay, so our topic today is finding stationary point and their nature. Before we go further, we need to know what is actually stationary point by take a bit understanding about the theory. So the stationary point is the point where the curve is changing direction. As you can see, the curve here below. So you can see that the curve is goes up first, and then like this, and this goes down. Okay, and also like this, and so goes up. Okay, so we can determine the point are along the transition, the gradient of this point. Yeah, so let's say if I want to know the gradient in this point, so I can draw the straight line. This represent as a red line. Then the gradient is positive because the curve is goes up, right? And if I want to know the gradient here, lies here, so draw again the straight line, and then also we can see that the straight line is horizontal, and the gradient must be 0. Okay, let's next, because the curve goes down, then the gradient will be negative, right? Okay, again, horizontal and up goes up, positive. Yeah, so actually the stationary point is this point. So when the gradient is equal with 0. So I should know that the gradient is very easy to find by do the first derivation of the function. So the first derivation of the function is equal with 0. We can find the stationary point then. Okay, and the next topic is about nature of point. So after we got the stationary points or the coordinate, then we can determine whether the values or the coordinates are local minimum, local maximum, or point of inflection. So if I have the curve is like this, so you can see that the curve goes down and then goes up. So the order of the gradient is minus, 0, plus. So we can see that this point, we can say that this point is a local minimum. Okay, let's go next to this example. If I have a curve like this, and then also you can see that the curve goes up, then the gradient will be 0 and then negative. So this point is called the local maximum. And the third one is point of inflection. When you have the curve is like this, having the gradients positive, 0, and so positive, or negative, 0, negative. So we call it as a point of inflection. Okay, so there are 3 possibilities of nature of point after we got the stationary point. So to find the nature of point, there are 2 ways. First is nature table, and the second is second derivation. So the nature of table is like this, and I will explain to you more deeper about the example later. And for second derivation, is actually we find the second derivation of the function, and then we substitute it with the stationary point that we got before, the x values of stationary point. If the values is less than 0, So so the nature of point is local maximum. So it's like a contradiction. When the value is less than 0, so the nature of point will be maximum. And if the values is more than 0, after we substitute it with the x value from stationary point, then we call it as a local maximum. So the rule is like a contradiction like this, so don't be confused when you do the second derivation, but the second derivation is more simple than the nature of table. Okay, so here it is the exercise. So we need to find the coordinate of the stationary point on the curve y is equal x power 3 minus 12x plus 5. And also we can determine the nature of point of this function. Okay, so let me share my whiteboard. Where is my board? Okay, this one. Okay, so I will write down again the questions. X power 3 plus 12, oh, minus, yeah, minus 12x plus 5. Okay, so here it is the function. If we find the first derivation of the function, it will be 3x squared. So I get this value because you can see that the power here is 3, and also the coefficient in front of the variable x is 1. So 3 multiplied with 1 is 3. Yeah. And because the derivation calculation is we need to minus the power by 1. So here we have 3 minus with 1 is 2. Okay, so I hope that you already know the next value is this. It will be just minus 12. Why? Because the power here is 1. So 1 minus by 1 is 0. Anything that you power with 0, it will be the value is 1. Okay, so minus 12 times 1 is minus 12. And the next is 5. So the derivative of 5 is just 0 because 5 don't have variable, right? Okay, so the power is 0. 0 multiplied by 1. Yeah, we cannot make a derivative of this because these don't have variable. Okay, so as we know that the stationary point is f dash x, yeah. If f dash x is equal with 0, right? Okay, so here we can write it again. 3x squared minus 12 is equals with 0. Because the form is haven't simplest yet, so we need to make it more simple by dividing it with 3. So it will become x squared, right? Minus 12 divided by 3, it will be minus 4. Okay. Then if we want to get to know the value of x, so we need to factorize this form. It will be x inside of brackets and also x. We need to think the number behind this x. So we need to think to number that we when we multiply it, it will be the result minus 4. So what are they? Of course, minus 2 and plus 2, right? And also you can check your answer, whether your answer is correct or not, by multiply each of this, and then you can sum all of the value, and is if you got this form, so you are correct. Okay, I think you can check it later, this factorial. Yeah, and the next is we have here is my x minus 2 is equal with 0, or x plus 2 is equal with 0, because here we just want to know the value of x, then we need to move this number to the right hand side. Remember, when you move the number in the right hand side, we need to change the sign, yeah? So x equals with 0, or oops, x minus 2, right? We already know, yeah, the stationary point, which is x value. But we need to know the coordinates, so we also need to know the value of y by substitute each of those value into the function. Okay, so here it is. I will, if the x value is 2, y value, okay. So we just need to substitute it by 2, right? So x power 3, then it will become 2 bracket power 3 minus 12x. X we substituted with 2, yeah, plus 5. Okay, so you know that 2 power 3 is 8 minus 24 plus 5 is, can you guess the value? It will be minus what? Okay, minus 11. Okay, so the coordinate will be, I will make it with red ink. So 2 point minus 11. Okay, then if we have the x values is minus 2, we substitute it into the function as we did before, minus 2, yeah, then minus 12 multiplied with minus 2 plus 5. Okay, so we will get minus 8 plus, yeah, because minus multiplied with minus, then it will be positive 24, yeah, plus 5. So the value will be 21. So we have here is a minus 2. So the y value will be 21. So then the last step, we need to determine the nature of those points. Okay, the nature of those points, yeah, this one and this one. Okay, I will make it clear because we just have one whiteboard. So first is I want to make a nature table. Oh, sorry. Let me erase my writing because it's not clear. A nature table. Okay, so nature table is really simple to remember, yeah, that we have x value is minus 2 and 2, right? So then I give some space between those number, and also in the left side of those number and right side of those number. So because here we will do some of the tests, yeah, so you can use the other number. Yeah, so what is the number that is less than 2? You can test it by -3 or -4 or -5 is okay. So I will use the black ink. For example, here I have -3, this is 0, and this one is 3. Yeah, okay. So this one is the gradient for f dash x, because we already know that the gradient in this point, in the stationary point, is 0. So we can write it as a 0, 0. Then we need to substitute those numbers, -3, 0, and 3, into the first derivative of the function. Let me write it again here. So the first derivative is 3x squared minus, oops, okay, minus 12. Oh, sorry. Let me erase this and then write it again. 12. Okay, so we need to substitute. If the value is -3, then can you imagine that the x squared of -3, -3 substitute with into the x here. So -3 power 2 is equal with 9. 9 times 3 is 27. 27 minus 12 is a positive value. We don't need to know the exact number, so we just need to know the sign. Here is positive. And if we substitute it with 0, so 0 squared times 3, 0, 0 minus 12 is minus. So that value will be minus. And if we substitute with the 3, so 3 squared is 9 times 3 is 27. 27 minus by 12 is a positive, right? And the next is shape. So we can imagine the shape of the curve. Positive, so goes up, horizontal, goes down, horizontal, goes up again. So we can draw the curve is like this. Goes up, 0, goes down, negative, 0 goes up. Okay, so the curve will be like this. So the value here, so the value here, it will be -2. Oops, -2 point. I forgot -2 with 21, yeah? 21. So this one is called as a local maximum. Local maximum. So these points or this coordinate is belong to the local maximum. And also next we can guess exactly what is it is of course local minimum. So this coordinate is 2 with -11. So the nature of this coordinate is a local minimum. Okay, so we already determined the nature table, yeah, to find out the nature of the coordinate. After that, we can also use the second ways. This is more simple actually. In second ways, to determine the nature of coordinates is by using second derivative. Oh yeah, I think that I will type in second derivative. Okay, second derivative. So we first need to determine the second derivative. So we can write it as a f dash dash x from this. Yeah, we already know the first derivative, then we can just like continue to find out the second derivative. Okay, so like usual, you know that the derivative of this form is 2 times with 3 is 6x, yeah, because the power is 2 minus by 1. And then 12 is just 0. So the second derivative, the minus 12, if we derivative this is, the value will be 0. Okay, so we already got the second derivative of the function. And then the next step, we need to know the substitute value of the second derivative if the x, yeah, if the x is minus 2. So the y dash dash will be 6 times with minus 2 is negative, right? So negative 12 here is less than 0, right? So if less than 0, we could say the nature here is a local maximum. So the rule is like contradictive. If the value is less than 0, so the nature of this point is a local maximum. Yeah, don't get confused about the second derivative ways. Okay, so let me continue again with using black ink. If the x, yeah, if the x, oh, this one is still red ink. We'll use black ink. If the x is 2, so the second derivative value will be 6 times with 2, positive 2, it will be 12. Okay, so 12 is more than 0. So the nature of this point is local minimum. Okay, remember that the rule is like a contradictive. Okay, so that's all for today's lesson. We already know how to determine the stationary point and what is the stationary point, and we can get to know about the nature of those points, whether the nature is local maximum, local minimum, or point of inflection. Okay, that's all for our lesson today. I hope you can understand about the stationary point and nature of point after seeing this course. Okay, thank you. Bye.